Welcome everyone. This is Mike Clark. I just opened the front door here so we can get in. We will start um, the session here in just 1 minute. Good morning everyone from a cloudy, rainy California morning, or good afternoon depending upon where you are at. My name is Mike Clark. I will be the moderator today for our our database administration virtual chapter group. Today's topic is Query Store. Our speaker today is well-versed and well-skilled Tracy Bojano, and we're looking forward to a great session today on the new Query Store. This presentation is part of a bigger, the virtual chapter group is part of PASS. It's a large organization called the Professional Association of SQL Server. There's virtual groups in many different disciplines and topics. On this screen there's language groups, there's actually vertical groups, there's technology groups like PowerShell or Excel, there's architecture type of groups on how to build things, there's high availability and disaster recovery. There's basically a virtual group in almost any topic that would be interesting to the SQL Server professional. If by chance you happen to see a group, or happen to think of a topic or a group that's not represented by a virtual chapter, feel free to reach out to volunteer at sqlpass.org and start the process to maybe begin that group. You might be a virtual chapter group leader, and if there's a need there, then go for it. That's how this works. You see a need, you propose it, and then you can drive that need. One of the other things that's part of PASS, the parent organization of PASS, is a SQL Saturday. That's kind of how it says. It's SQL on a Saturday, and so they're global now. This is the upcoming list. It just so happens there are no SQL Saturdays this Saturday. That's a very rare thing, but usually there's SQL Saturdays every Saturday of the year. We just missed one in Istanbul. They're international. There's none in the U.S. this weekend at all. But if you go to SQLSaturday.com, you can see all of the current, future, as well as past SQL Saturdays. You can review the schedules, the speakers, see the topics, and so forth. Our today's speaker, Tracy, she'll be speaking in the DC SQL Saturday coming up here in the next couple of weeks. And if you go to SQLSaturday.com, click on the Washington DC SQL Saturday, you can actually see her session and all the other sessions and abstracts that are going to be available at that SQL Saturday. SQL Saturday is a great way to spend a day to cover a lot of SQL topics, meet a lot of folks, and maybe one of these days you can do a presentation at SQL Saturday as well. It's a great place to learn, to network, as well as to teach and train others in what you've learned in SQL Server. And there's also a physical chapter. We've been talking about kind of a virtual group, and we have a SQL Saturday group, but there's also a monthly group for SQL Server itself. I'm in Silicon Valley, so I actually meet at the Microsoft shop here right in Mountain View, California, and we meet on a monthly basis there. There's also a business intelligence group that meets in San Francisco, just up the road a bit, but there's bound to be one fairly close to where you are in person, and again, if not, then you could propose something to SQL Pass itself and say, I'd like to start a physical chapter in my area, and then we can send you information on how to get that going. So if you're interested, excuse me, I got a catch right here. If you're interested, there's you can send an email to CE at sequelpass.org. And like I've been promoting so far is PASS is run by volunteers, so if you're interested in helping out at PASS in any capacity in one of these chapters we're talking about here, even at the summit, you can volunteer at that. If you go to volunteer at sequelpass.org, you can register there your interest, or you can go to the sequelpass.org website and click on I'd like to volunteer and help out there. And so that's how you get started, and that'd be a great way to add some help to the SQL Server community. We're also on all the other. So if you found us on YouTube, we have all of our recordings for this virtual chapter for the past several years. I've been doing this about 12 or 13 years, and we have all the recordings from all of the monthly sessions there. So any topic that you'd like to cover, most likely we've either covered it or it's on our future agenda to be covered. But if you go to sequelpass.org, you can become a member, and then you have all the YouTube channels available, YouTube channel videos available to you to peruse at your leisure. And we're on all the social media, from Facebook to Twitter, LinkedIn. Feel free to connect with us that way. If you go to pass.org, that is actually the parent organization to sequelpass.org. Either one of those, they're interconnected. You can get from one to the other and from the other back to the one. And so with that, I'd like to get us back to today's topic, which is a query store primer. As I've already mentioned, Tracy is our presenter today. She's a DBA for Channel Advisor. She has 20 years plus experience in the IT industry, and she's been working with SQL Server since 1999. She's certified in data platform. She's worked with SQL Server since 6.5, which for those of you who knew, that's a long time ago. She's currently a co-leader of special intergroups for advanced DBA topics, which this is one of them she's presenting today. She's cross-pollinating with our group today. We appreciate that very much. She's also looking at bringing Unix content into various virtual chapter groups, which I'm interested to hear more about from her. I'll have to connect with her offline on that. I'm very much into working more with Linux, so I want to see how we can leverage that. Of course, she blogs at databasesuperhero.com. Her passion outside of SQL Server is volunteering with foster children as their advocate in the court system. And she might mention that in her upcoming presentation, but that is a great way to give back to your community. It's not technology related, but it's a great way to give back, being a CASA for kids in foster care system. And with that, I would like to have Tracy be presenter here. And so with that, Tracy, I'm going to make you presenter. Really, I am. There we go.
There we go. All right. Here we go. It's like I said, we're going to talk about Query Store Primer, and I'm Tracy Baggiano. My new title is Database Superhero, so I've themed up my slide deck to correlate to that. And as mentioned, I do lead a special interest group in advanced DBA topics. If you happen to know anybody that wants to speak at that group, let me know. I am leading Getting Linux sessions into the various past virtual groups. We've actually got a Linux PASS marathon coming up on December 13th, actually scheduled through PASS as well, that I've tweeted about if anybody wants to get information on that. I do volunteer through CASA in North Carolina. That's called the Guardian Ad Litem program. It only takes about 8 hours a month, which equates to about 2 hours a week. So you get to advocate for abused and neglected children through the court system. I'd love to talk someone into doing that because it's a great use of your time. I have a cat that likes to jump on my computer, so I started adding her to my slide deck. So just in case you hear any meowing or jumping on keys, that's the cat. Her name is Quake. She's after my favorite comic book character. There's my contact information, just my email, my Twitter, and my blog. So feel free to reach out to me afterwards with any questions. What we're going to cover is what is Query Store, what you got to do to set it up, what your different usage scenarios are for it, some extended events that are important, your best practices for using it, and we're going to look at some community tools that have been built around QueryStore, and then we're just going to sum everything up. So what can QueryStore do for us? The main thing that QueryStore can do for us is if you've got a query that's regressed in performance, you can actually go in and see those queries that have regressed in performance and fix those queries and tell it to use an old plan, and then those queries will start performing better. You can use it to determine the number of times a query was executed, so you can see when you got a particular query that's executing 1,000,000 times versus some that are executing only 1 time. You can identify what queries are running at the top resources on your query, so you can do that by CPU, memory, reads, writes. You can audit the history of all your query plans for a given query, so you can have up to 10, 12 different plans, many more, depending on how your system acts for a particular query, and you can go in there and you can determine why you're having those issues, which plan's the best, and decide on which one you need to use. And you can also use it to analyze your resource usage patterns for a particular database. So over time, if you have this turned on, you can see if your CPU is high, or if your execution count's high, or if things are just taking a long time to run, and try to tell if a particular change has been rolled out as to why that particular change might have caused that issue. In 2017, we've also introduced the ability to see wait stats for each query. And that's rolled up into categories, into 23 different categories. And they've also got a feature called auto plan correction. Instead of you having to go in and push the buttons that tell it to use an old plan that's good, it'll actually go in and do that for you. So how do we go about setting this up? Well, it's really simple. You just got one command to turn it on. Now, with everything with SQL, of course, it's not that simple. It is that simple, but there are a couple of things you'll want to change. The main thing we want to change is bullet number 4, which is our max size. By default, that's set at 100 megs, which means it really can't keep that much data, so it's trying to keep all your query plans for you. You need to set that a little bit higher. My recommended size is 2 gigs. We're running on a system that gets 30,000 transactions per second, and we are able to keep over 30 days worth of data at the 2 gig interval, and we just let it automatically clean up. Now back to the other options, we usually leave those alone, but our operation mode can be in read-only and write, and I don't see any reason why you'd want it in read-only unless you just don't want to capture data, but there could be a reason for that. But you want to make sure it stays in the read-write mode. There are reasons that SQL will automatically put it in read-only mode. If for some reason you don't have it set to clean up and it runs out of space, it'll automatically flip it to read-only because it can't take any more data in. The data flush interval tells it how often to flush that data to disk, because it currently uses Hekaton or in-memory OLTP to keep that data in memory until it flushes that data to disk. And that's set to every 15 minutes. Now, I do know from personal experience on my laptop, if you set that to every minute, it'll become the top consuming query on your laptop. So I do not recommend changing that any lower than 15 minutes, especially in production or even in development. So your statistics collection interval is another option that you may want to change. This tells it how to roll up your data. So when you're looking at the statistics, it by default rolls up all your statistics by the hour. So if you want to see the execution count for a particular query, it rolls it up to a particular hour and tells you it ran X number of times in that hour. You may want something a little bit more granular, like 15 minutes. We've got ours set to 15 minutes, and we're not hurting any on the space at 2 gigs or on performance. So that's just going to depend on your system and what level of granularity that you want. The QueryStore capture mode is by default set to auto. You can set it to all or none. Again, none would be a bad option, I would believe, because then you would basically be capturing nothing. Auto tells it if it's a trivial plan, not to bother to capture it. So if you're running like a select one or a select star from a really small table, it may not capture it because it doesn't consider it to be a big enough plan or have enough statistical impact on your system to need to capture the data. So if you really want to see everything, you're going to want to set it to all. Your size-based cleanup should be set to auto if you're going to make sure it doesn't go into that read-only mode in your operation mode. And your state query threshold of days is set to 367. They took in leap year in a day for us. So you'll want to make sure you probably at least leave that at that date unless you want want it to chop off your query plans sooner than that, if you don't want to keep those query plans in the system longer than that, it by default will flush out the things that are older as it needs to based on your cleanup schedule. So some of the things I don't like about how Query Store is set up. By default, Query Store is on your primary file group. Now, if you decided that you wanted a very large query store and wanted to keep like a year's worth of data, and you have an environment where you set up all your tables and indexes in a different file group besides your primary file group, and you want to do piecemeal restores, that could slow you down a little bit when you try to do piecemeal restores because everything would be in that primary file group. Now, my boss opened up a connect item to have this upvoted so that the query store could be in a different file group other than the primary file group. That way we could help out with the restore time for piecemeal restores. I usually, when I do this in person, make everybody raise their hand and promise to upvote it. I can't do that on a virtual presentation, but I'd appreciate some upvotes on that if everybody can do that. Some trace flags you want to be aware of when it comes to query store. Because the data is in memory, you can force it to not flush the data to disk if you tell it to shut down. So that's trace flag 7745. Now, if you're noticing that your system is taking a long time to shut down and you've got lots of databases on that particular server, you may want to turn this trace flag on so that it just loses that 15 minutes worth of data that's in the in-memory OLTP. Another trace flag is a 7752, and that tells it to load the data asynchronously when you're turning the system on. And you'll notice a wait type of QDS load DB. If you see that and you're experiencing that high number of waits in that area, you may consider turning that trace flag on for when you're rebooting your servers. We've turned both of these on and off because we didn't notice a difference when we turned them on. So another one of my pet peeves for Query Store is that it's set up per database. So as you can see on the right, I have lots of databases. I actually have one server that has 400 databases. I think it's this particular server. I can't squeeze 400 databases on a print screen. But it would be nice if they had a central repository on the server. That way you could just go in and find the particular database that has a problem. So I'm hoping one day Microsoft will build us a central repository for Query Store. That way we can easily identify a problem on that server and find the exact database that is causing us an issue, rather than us having to guesstimate as to which database it is. I do have a PowerShell function that will query across all the databases and you can pull data out. But again, across 400 servers, that might take a little while, or 400 databases. So let's take a look at our setup options and how to set it up. Again, as far as setting it up, you very easily just turn it on. I'm still using AdventureWorks. And then you'll get a nice little folder with Query Store in it. When you go to the properties of the database, we're going to kill our workload that I'm running so you'll have stats later when we look at reports, just so the system will run a little faster. And now I have a Query Store option, and it has a little bit of data in it, and you can see all your options that are set. Not sure how well this shows up virtually, so I'll zoom in. But it says rewrite, and you got your data flush interval of 15 an hour, and by default our max size of 100, and it's telling us to capture all the data. And I got an auto cleanup and 367 as our data flush. So it's as simple as that to set it up. Like I said, I'd recommend changing the size up a little bit so that you can keep your data longer and not have it go into read-only state because you didn't have enough space. Now we'll talk a little bit about how it actually works. All right, I got this picture out of the books online. So it starts by executing the query, then it looks for the plan in the plan cache. And if it finds the plan in the plan cache, it decides if it needs to compile or recompile the query. At that point, it looks in the query store and decides if there's a forced plan or not, and we'll talk more about forced plans, as we mentioned those when we talked about regress queries. And if the plan has been forced, it skips over the recompile process and pulls out that forced plan. If it doesn't have a forced plan, it goes through the process of fetching the plan from the cache and using that, and then checking for the recompile. And if it's not needed, it just doesn't recompile it, and then it executes the query. And once it's finished executing, the really cool part is the gray arrow on the side, where it takes all that execution stat data and it stores it in the query store. And now you know how long it took to run, how much memory it used, how much CPU it used, how many reads it did, how many writes it did. And you've got all this cool data that you could only get before by using a server-side trace or running an extended event session. Now, some usage scenarios for Query Store that you can use to do things. We've talked about regress queries. So it can help you identify all the queries with the metrics that have degraded over time that you're interested in looking at. So we've had instances in my environment where on Christmas Eve, I've had Mr. eBay page me and tell me, hey, this particular store procedure's running poorly for a particular customer, and he tells me what database it's in. And I go in there and I find the query, and sure enough, you can see in the charts that this query has one plan at the top and one plan at the bottom, and you can tell that it's degraded in performance. You can easily tell amongst those regress queries which plans they are and which plan to choose, and now they have the ability where you can actually compare the plans using the new Studio Manager. I think that came in 17.3 Studio Manager. So you can actually compare the plans inside of Studio Manager, and then you can just force that plan from the history, and then you don't have to work so hard on Christmas Eve to do things. I did use the GUI, and my boss was disappointed that I didn't use the SQL syntax, but it was Christmas Eve. I got this out of Books Online as well. This is a demonstration of what a regress query would look like in Query Store from Microsoft. They had a query that they ran, a good query, and then they ran a bad query, showing up at the top that it took 20,000 more milliseconds to run on average, and then they ran it up and down, up and down, and up and down, and then they decided to force that bottom plan because it was a better plan. This is what it looks like in the real world. You get one plan that runs really good, runs at 0 CPU, and then you got one that runs up at 6 million. So in this case, you'd really want that green one to run most of the time and not the pink one. So this is what you would see on your systems, and you would go, aha, I want to look at this green one and see what's going on. I want to look at this pink one and maybe see why I'm getting the pink one and maybe fix my stored procedure. But in the meantime, let's force this query, and then let's go back and look at this stored procedure and see what's happening so we can figure out why we're getting this plan that's just off the charts in performance. So there are instances where after you force a query, it will fail. If you change an index that plan is using, it will cause the plan to fail. You just got to change the definition of one of the indexes in there, and it will fail. So in the new Studio Manager 2017, they added a report for that. I used to work in shops that wouldn't let you upgrade to new Studio Manager, so just in case you have that problem and you're stuck on 2016 Studio Manager, there is a query right here that you can run to see what your force plans are. Hopefully you don't have that problem though. Hopefully you can just use the new Studio Manager and see what your force queries are. This is a demonstration of a report that will show you the overall resource consumption on your system. It shows you, in the top part, it shows you the duration. On the right-hand side, it shows the execution count. At the bottom, the CPU and the logical reads. And we can see based on the charts that at some point, the CPU and the logical reads just dropped significantly on our system, which was around the time we did a release at our company. And everything else stayed the same, and we actually started executing things more. And this is what I mean by you can actually look at a particular database and get your resource usage stats and kind of say, hey, this is what's going on with my system, and you can drill down in each one of those bars and see what was happening on that particular day, and try to figure out what needs to be looked at and what doesn't need to be looked at. Now, your top consuming resources would be the report you would get when you drill down on there. So it would show you by query what was going on, and that's where you would look at forcing a plan because it has regressed, or you can take a look at what indexes are missing because it will show you the plans down at the bottom with the missing index hints. You also want to make sure your statistics are up to date, and an example I'm going to show you later is an example of an ETL load, and the statistics are out of date, and that's why you get a bad plan. You also want to make sure your indexes aren't fragmented too badly. And you may just want to consider rewriting an expensive query. It could be just the query is just not written perfectly. Some DBs, the database developers need a little bit of help on writing inexpensive queries. Another cool report that they added in the new Studio Manager is queries with high variation, which just shows you one query in particular that varies in how it performs, and it's not because it has a different plan. So you can go in and look at this and see that things are just performing erratically on a particular query and decide that you need to take a look at things. And it just gives you a different view on how to look at things. So we're going to take a quick look at the reports based on what I ran against AdventureWorks.
Hey Tracy, I have a quick question for you.
Yes.
So if you have Query Store running, what's the load that it generates? Is it detectable, and where does it kind of show up? CPU, I/O, or something else?
Like I said, we instituted it on all our systems, and we're running between 30,000 transactions and 60,000 transactions per second, and we didn't notice any overhead at all when we enabled it on our databases. And we've got upwards of 30 databases per server. So the marketing says maybe 2% on the CPU, but we didn't even notice that much.
Okay, wow, that's impressive.
I thought so too. I was expecting to see stuff, but part of that's because 2016 they built a lot of stuff into it, and 2016 is just faster than it was before. So I think the overhead got better just because of the fact that 2016 is faster than 2014 was.
Connor did a good job on this.
Oh, that's the wrong database. I go to the workload database. So we can see where I ran a workload today against my AdventureWorks workload database and yesterday, so we have some charts to look at. And most of the stuff comes in duration, and we got a little bit of CPU time and a little bit of logical reads. And if we drill down on those, it automatically takes us to our top consuming report, which is right down here. And we can see we have some variations of the times, and some of these are stop times, so that's every time I rebooted my computer to do other stuff. Those squares always mean that it failed to run, and those are things where I had stopped the computer to do things, because my computer can't run 24/7, unfortunately. But for every query you get in here, you can see the execution plans down here. This is a very gnarly looking execution plan. One of my favorite views is to actually go into the grid, where you can actually see the stored procedure name. So then you can actually sort and look for a particular stored procedure if somebody's complaining about a stored procedure. And you can actually sort by the columns too, by duration, if you're looking by duration. And you have columns up here too for your execution, CPU, reads, writes. They even added CLR and DOP in here as well. Those are recent additions as well. And they've added wait time as well, since they started tracking wait times, and that's only available if you're running 2017. So you can take a look at those different things. If we had multiple plans, we could take a look at compare the plans together. We'll see if we can look at that when I do my demo. But you can look at this in grid format as well, and it would show you the different plans and their average wait times, and you would get a view of that. We don't have any forced plans, so we'll take a look at that report later. We'll see if we got any high variations going on. We got a few. They're not really that high, from 0 to 12, but here's an example of what the report looks like. And if for some reason you had a particular query that you wanted to look at, like 277 right here, you could take it into the tracked queries. For example, if I had forced a query and I wanted to go back and look at it over time, I could put that query in there and see what it was doing over time. So, and each one of these is configurable, so you can go in here and tell it how far back to go. By default, it goes back to the last day, but you can go back for the last year, month. You can put in your own custom time range, and you can tell it which field you want to do there. So those are all the reports that they've got built in so far into Studio Manager. I hear there are more to come, hopefully with weight stats. That's my dream. I like weight stats. So back to some more usage scenarios. When you're rolling out a new version of your application, you can make note of what time you're doing that and have Query Store available to tell you, hey, my performance improved, it got worse. You can drill down and see what got worse. If you're adding new hardware to the server, you can see if it made a difference in the area you expected it to make a difference. If you created some missing indexes, you can see if it made a difference on that particular query that you're looking for. You can also see if other queries got worse, because you know sometimes it affects other things. You can also use this to identify and improve any ad hoc workloads you got, because the more ad hoc stuff you got going on, the bigger the Query Store gets, and the more work it has to do to keep up with stuff. Another use case scenario for it is when you're trying to upgrade from a prior version of SQL Server that doesn't have Query Store. You can upgrade it to 2016 or 2017, and you can leave it in the old compatibility level and let Query Store run for a week or 2 or 3, however long you think you need to run to capture a good workload. And then you can change the compatibility mode up to 130 or 140, depending on which version of SQL you went with, 2016 or 2017. And then you can use Query Store to force any plans that regressed in performance because of the compatibility level. And then you can go and work on fixing those queries, and you don't have to worry about the fact that you upgraded force something to perform badly. And this is something you particularly had to worry about when they updated a cardinality estimator in 2014. So this is something that you don't normally have to worry about, but there are cases where you do, so it gives you the ability to quickly and easily force things to go back to an old query plan, and you don't have to worry so much about your upgrade breaking something or making something run slow. As far as identifying your ad hoc workloads, when you're in that top consuming resource consumption report, you can sort it by execution count, and you can see where everything's only executing one time. And you can try to identify each one of those and see if those queries are the same. There's actually a query you can use on Books Online where you can pull those out as well and try to see if those are the same, and try to turn those into a stored procedure in your application. Then you can actually see that this is happening 100 times a day or 200 times a day, and if performance needs to improve, there needs to be an index and things like that. You really can't tell those things if people are running ad hoc queries against your system. So it's better to have stored procedures if you can, especially if they're running the same type of queries. So this gives you a way to actually capture that data and analyze it and see if you need to convert any of your stuff into stored procedures. And that was just what I said in words. And this is just to sum up what our usage scenarios were, so we can pinpoint and fix our queries with our plan choice regressions. We can identify and tune our top consuming resource queries. We can use it for A/B testing for anything that we've upgraded or adding indexes. We can keep our performance stable during the upgrade to SQL Server, and we can identify and improve our ad hoc workloads. So, new in 2017 is a added weight stats. So there's a new DMV called Query Store Weight Stats, and what this does is by query it'll track your weight stats by that runtime interview in the categories such as CPU or memory. And currently they only have 23 categories because there's like thousands of weight stats. Maybe not thousands, but there's lots of them. So that if they kept every single weight stat, Query Store in that 2 gigs would just be blown out of the water. So you need a lot of space to keep that. And they're all documented on Books Online as to which ones got documented into which category. So you can take a look at that and see which things got into which category. They also, in 2017, enabled auto-plan correction. And this is something that I've been playing with in Azure because they've been putting a lot of their stuff into Azure before they've been releasing it to us. So but you can look at the recommendations in the DMDB tuning recommendations, but by default you can just turn it on and it will force the last good plan, and it also has the smarts to turn that plan off and if it turns out to be a bad plan later. So it's really slick how it will do that. So it can automatically switch to a good plan and say later on, hey, this plan's no good anymore, and switch it off. So the data's in a DMV if you choose to be a DBA that's more cautious and you want to be the one that turns it on yourself, and it can give you recommendations and it can tell you what performance improvements it would do, and you can query that data. So we're going to go through an example of forcing a plan. I'm going to show you my PowerShell script that will query across databases, and we'll look at the DMV query with WaitStats. So I got this example from Slava, and I can't say his last name. I should ask him one day. I see him a lot, but I haven't figured out how to say his last name yet. So we're just going to use AdventureWorks, and we're just going to delete some data just in case I didn't delete it last time, and I didn't, so it's a good thing I deleted it. We're going to drop the index I created, and we're just going to create an index on sales order header with the order date, and we're going to free my procedure cache and update our stats so everything's just a nice fresh start. That's all we're doing, is giving AdventureWorks a fresh start with an extra index on it. Why is the white showing up? I don't like it. I shall open it again with no white. That's better. So we're going to look at our main query, where we're just going to query for stuff that ends with the last name of Martin for the month of July in 2014. And we're not in AdventureWorks because I closed the window. And we're going to get no data back, which is what I was expecting, so that's good. And we're going to do little to no reads because there's no data there. And this is our execution plan that we get. A nice little execution plan. We'll determine later whether that's a good plan or not. Now we're actually going to get some data into that July data. So what we're going to take is we're just going to take all of June's data and add a month to it. So this just mimics like an ETL load. So now we have that 939 rows in there. Now we're going to run, and because we ran that query, this is going to look a little expensive because it's doing all this extra work. Because it's going to done 2,000 reads and 2,000 logical reads and it's actually doing physical reads off my machine. And we still got our same execution plan where it's doing a logical non-clustered read and a key lookup. So we're going to see if we can't get a better plan out of this by updating the statistics. Now we got a plan that only did 700 reads, and we got a much tighter execution plan where it's only using our index that we created and the last name to figure out our person that was named Martin, and we're still returning all our rows. So now we'll take a look at what that looks like in Query Store. So we've got this plan down here where we had the really small execution plan and a plan up here. So in general, if we're going to load this data every month, or if this turns into a daily load and we have bad stats, we're going to want to force this plan down at the bottom so that every time we load, we don't have to worry about updating our stats and keeping things current so that it runs a good plan. So we're just going to hit the Force Plan button down here, so that every time we run that query from now on, and as you can see, it puts a little check mark on it saying it's a forced plan. So now every time we run that query, it's always going to return that same query plan. So no matter how many times I run this query, I'm always going to get this plan, even if I delete the data and start over. So I'm just going to clean up after myself, even though I have all the stuff at the beginning to do it. And that's how easy it is to force a plan. So you'll go in and you'll see two plans like that, and you'll probably see multiple variations like we've seen it in my chart, where we had a bunch up at the top and a few good ones down at the bottom. And you'll see that it's very easy to pick which one. You won't have just one and say, oh, that's a good one. You'll see more dots than what we've seen when you go to do it in production. Now I have this function that goes across on your server and will query all your databases and return based on what metric you send in, whether it's execution, duration, CPU reads, writes, memory, or row count. The top consuming queries per server, and it'll give you the top 10 per database that have been minimally executed 10 times, depending on how many you send in. We're going to probably set it lower because we've had the workload turned off. And you can just run that function, and it's going to turn data into a grid that you can look at, and then you can sort based on whichever column you want to look at. So we got some AdventureWorks stuff here, and we got some AdventureWorks workload stuff here, and if we want to sort it by CPU time, we can see this is the one that took up the most CPU. So if we were CPU bound that day that we were looking at, then this is the one we want to take a look at. If we're concerned about some other metric, we could sort by that metric and look at that, or run it by that metric and look at that. So that's just a neat little function I wrote because I have multiple databases on the same server. And we'll take a quick look at the categories that my server has generated so far based on the workload I ran. So we get a buffer I/O, and I've generated 15 of them. That's all I seem to be able to generate on my machine, and there's 23 of them. It's nice we got an unknown one. Well, we've generated a few different workloads, so that's the different categories you can see on my machine. We're mostly waiting on buffer and CPU on my machine. So if we pick a particular query ID, hopefully this query ID still exists, and it does. We can look at it for a particular runtime interval. If we link that back to the runtime interval, I'll actually show you a better stored procedure for looking at this data later. You can actually see what weights we're waiting on that time interval. Brent Ozars actually wrote a stored procedure that'll pull this data out for you that looks better than this. So we'll take a look at that and get you a better look at that data.
So Tracy, I have a question for you.
Yes.
So if you have Query Store enabled and it's running for a while, can you delete all the entries in the Query Store? Say you wanted to start with a clean slate for...
Yes, there's a command for that, and there's a purge data on your setup screen. If you go to the setup screen, you can actually purge the data. And there's actually a command for it as well. I don't remember the command off my head, but you can actually hit the purge data if you wanted to flush all the data out. And there's a stored procedure for it as well. You could be testing something for some reason and want to do it. Hopefully you don't want to do it in production, but you may. There may be a use case for it. But as far as extended events go, we've added over 50 extended events. I've only found 3 to be curious. So the first one is the Query Store regression one. They actually have it. It exists in 2016. It just doesn't fire, so don't use it there. That annoyed the heck out of me. But it does work in 2017, so you can actually set up an extended event to know when a query regresses across your whole server, and then you know to go look at it. How cool is that? You don't have to go database by database looking to see when things regress. The other one is to know when your Query Store goes into read-write and fails. So you may want to know that across a system that has 400 databases instead of finding out later when you're trying to troubleshoot something. You also may want to know when your plan that's been forced is failing. Again, if you have 400 databases and you've forced a plan in one of them, you may not remember which one you forced a plan in. So you may want to set up an extended event that you check every now and then to see when these things are happening. So those are the 3 I recommend taking a look at and maybe setting up some monitoring around. As far as best practices, we've discussed most of these. So one is to manage the size, set to something besides 100 megs, or you'll be a sad DBA when you go play with it and it's in read-only mode, like I was. Set your statistics interval to something that matters on your system. Like I said, an hour may not be granular enough for you. You may need 15 minutes. You may want 30 minutes. An hour may be fine. It may be different for you on each system that you have. So, again, use the extended events or some other method to make sure that you're continuing to collect data. There is a DMV that you can query in each database as well. Avoid using non-parameterized queries. That goes back to your ad hoc workload because that just fills up your query store. There is a Books Online query where you can actually delete the ad hoc work stuff out of your query store so you can save space. Avoid using the drop create process for your store procedures. True story, my first DBA job, that's how they trained me to do it. Is you drop your store procedure and then you create it, and you opened up Enterprise Manager and you took a print screen of your permissions. That way when you created it you could go in and click all the boxes. Don't do that. Use Alter. It's a lot easier. And the other thing they say in Books Online is not to rename the databases. I'm not sure why it says that, but it's there, so it's on my slides for completeness. Some things you need to know around using in-memory OLTP is if you're going to track anything with a stored procedure, you have to turn it on using this special stored procedure here. Control query execute stats. Every time you restart the server, you've got to execute this special stored procedure again for that. If you use that purge button we were just talking about, you have to use the special stored procedure again. And there is a field in the query store plan that tells you which queries are natively compiled. So if somebody's already turned them on, you can go in there and use that to query it and find out which ones are turned on so that you can actually go make a script for when the query starts up to do this. Another thing you need to know is because it's in memory, it doesn't actually track the memory grants for you. So there's no metrics for memory grant for in memory. So some community tools that have been written around Query Store. Enrico has written some reports that you can look at on the database level and on the server level across your server, which help you find things. And Brent Ozar has written a store procedure as well that lets you query data, so you can query stuff by store procedure and see what's happening. So we'll take a look at both of those. So Enrico's query store by instance will show you everything by the server. And it takes just a minute to run. And I only have it turned on 2 servers, so but it tells you by default how many servers you got it turned on, how many unique queries per database, and my Adventures workload database is the one that appears there because that's the one I ran the most stuff against. And it shows you all the options that are turned on. Then it shows you the resource usage pattern for the CPU over the last 4 hours. Then it shows you the number of plans executed against those databases in the last 4 hours. So this can give you a way to look at your server and figure out which database is eating up the most resources and tell you which database to look at, like we were talking about before. Whoa, that zoomed in too much. And then he's got it by logical reads and logical writes as well. And then he's got the top 5 queries for the whole system down at the bottom. And I only have 2 that are running by his, oh, I got more than that evidently. Top 5 per database. And it tells you what compat mode each one of them are in. So you've got these query IDs in here, so you can use that tracked query report and go look at each one of these and figure out what they're doing and see what things are happening. So that gives you a good way to what's happening and try to drill down in them. And he's got one that looks pretty similar as far as at the database level. So it tells you your top 10 queries. I only have 4 that made the list in the last hour. The execution counts, the number of distinct queries and plans, the logical reads and writes over that period of time, and the CPU over that period of time.
Tracy, a quick question for you.
Yes.
So you've been showing us local on-prem of your machine. How much of this stuff actually transports, or is portable rather, to Azure? Like, can you see? Will this report you're running right here, will that actually run in Azure kind of thing? What's the comparison between on-prem and Azure?
I'm not sure. I'm not sure if this report will run in Azure, the server side one. I haven't tried to run a report in Azure, to be honest.
No, that's okay.
Somebody can email that to me and I'll try to find out. I have an account, I can try it.
Consider it done.
So, but it tells you the multiple plans over the last 8 hours. And then it tells you, of course, your configuration and how much space you're using. So, the other thing he has is what he calls a what's up query store that tells you what's going on with your query store. And it basically starts off by just telling you your configuration and whether you got any forced plans, things that were most executed in the last hour, most expensive things in the last hour, based on CPU, average time, logical reads. And you can just run that and get a baseline on your system, and it gives you a quick way to see things. And then, of course, you can click on it and bring up any plans and view it and see what you need to see in there. So that I know you can run in Azure because it's just a stored procedure that you create. And then I ran Brent's already because he has several variations of what you run. So one part he runs them all in debug method, but you can get your top query. You can do it based on a particular starting date I just put in today. You can put anything in as an end date. You can do both where you have a start and end date, so you can look at everything between a particular date. You can do something that has a minimum execution count, so everything that executed a minimum of 10 times would show up. You can set the duration of the minimum execution count, so it has to ran for 5 seconds at least. Look for a stored procedure that doesn't exist. I don't know why you would do that. This is his example, not mine. You can look for a particular stored procedure, and that's the one I find to be most useful for when somebody's troubleshooting something, is you're wanting to find something that's looking for a particular stored procedure. So I'm going to scroll down to that one because that one tells me the most data, so that'd be the second to the last. So it's telling me every time this query has ran, and it's telling me my query ID, so I can go in and I can stick this in EventualWorks and look at more data. And it's telling me my plans. And it's giving me my warnings that are in my plans as well, so you can take a look at those. And it's telling you your pattern of usage is basically your CPU is your most heavily used thing on this query. It's telling you your parameter sniffing problems if you have any, if it had a failure reason, and then here's where you can go to get your weights by the query. So like I said, I told you earlier I'd show you a better way to go and see your weights. This is the best way to go in and see them, is just go ahead and use Brent's query. He has them all locked in there. And it tells you every counts of execution, the current compiles, the CPU, and all the other metrics you need to know. So I need to name them all. And even goes into the context settings, because you can have different ones based on whether you ran it in Studio Manager or whether you ran it from your app. So, but that is all I have. I'll leave it open for questions. I've got some resource slides at the end that show you where I've got all this information from. And my contact information, so I'll leave it open for questions.
Hi Tracy, well thanks again for the presentation on Query Store. I'm going to put up, folks, I'm going to put up a quick little poll on Query Store. I'd like you to kind of answer that as we're kind of wrapping up here. But yeah, if you have any additional questions, please submit those. We can ask those. There was one question that was not necessarily related to Query Store, but it was a question I've heard in the past, so I thought we wanted to get on a recording. Is um, how do you get the books online? How did you referred books online a couple of times, and there's been a couple questions today that how do I get the books online?
Yeah.
Not a trick question, I don't think.
That's not a trick question. Well, the first link I hear is docs.microsoft.com is books online now, because they changed it, so I haven't got used to calling it docs. So that's one link to books online now. That's what they used to call it, is books online. But that's Microsoft's documentation online, so you can start there, and it'll have links to Query Store. This is an older link to MSDN for best practices, and then here goes the newer docs. I have to figure out what they call it. Docs online. I don't know what they call it. The new documentation from Microsoft. Because then they got some stuff on MSDN still on their blogs. And this one's a blog about auto plan correction. So I don't know what you call it anymore, but it's the online documentation for Microsoft. So it's docs.microsoft.com. So.
Yeah, so I think one of the quick answers would also be to Google your question and put SQL Server books online, and it'll probably come to the top. That's what I've done in the past to try and get the official answer. But just to share a little results here, I actually put a poll up that said, on which version of SQL Server are you running Query Store? 2016, 2017 were the two real options. Then there was another option that said not yet, but planning to in the future. And then the fourth option is never, in caps with exclamation points. So yeah. So I'm not sure how to share the poll, but I'll just say what it is. So 4% said never, 65% said not yet, but planning to do so in the near future. And I'm in that category because I've been pushing to upgrade to 2016 and been so far blocked from doing it, so I can't run it yet because 2016 is the first real version. But 30% are running it in production, 26% are running on 2016, and 4% on 2017.
Yeah, you should just get the 2017 now so you can get weight stats and autoplay.
Yeah, I would. Yeah. So yeah, that's out of 100 people voted, so that's not too bad. That's pretty good math. But anyway, so it's like 30% are using it because they can, and I'm not because I'm not on that version.
Yeah.
But anyway.
I did put a link in here for the poor people who aren't able to upgrade. There is an open source project called Open Query Store that you can take a look at, try it in development, and see how it works for you.
Oh, really? I see that now.
I didn't mention in the presentation, I haven't had a chance to try it out, but some people in Europe have worked on this. Enrico is one of the people that's worked on it, but it gives you some Query Store-like functionality. It doesn't give you plan regression, but it gives you the data capture.
I see.
That cool. You may be able to use it. It's supposed to be backwards compatible to 2005. So it's worth taking a look at anyway, especially in a development environment.
Someone asked a question. Maybe you can tell me. Someone said, "Can we know the TS for Query Store again?"
TS.
Yeah, I know. I'm like my poor little brain. If you're listening, Alvaro, can you explain what TFs are? But otherwise, we're gonna wrap up. No, but with that, that's pretty good. I'm going to. This is my first time hearing you speak, so I'm gonna go consume all of your content, young ladies. So you've done well. I've appreciated this presentation. It's given a primer. Hopefully, it's made folks that have not started to use Query Store a strong desire to do so. Maybe a strong enough desire to force their company to upgrade to 2017. So hopefully that's one of the things we want to do is to help people get better tools to manage their SQL Server in an even more efficient way. Yep. But with that, I'd like to wrap up and say thank you very much, Tracy. You have any final comments?
Nope, that's it. Like I said, just if you got any questions, feel free to email me.
All right. Thank you very much, everyone, and see you in 2 weeks. Talk to you then. Bye.